good old-fashioned AI is what it's called, but it's like the first form of AI. So when people kind of discuss AI in general, you know, the most basic level, which was like very famous up until about the, it's the 80s, 90s, a little bit later, is good old-fashioned AI, right? This is like where we can basically symbolically represent a problem domain, and we can represent them in a set of if then else statements. So this is conditional statements. If you've ever done like a choose your own adventure novel where you have choices and you can go left or right, this is pretty much like how AI was. You would know through a set of questions how to come to an answer. So this is used a lot in businesses and a lot with databases and a lot of, so this is how kind of like a lot of the original stuff happened. The only reason I'm saying that is just because if you're involved in the kind of, I have to give you slight background because these kind of topics get brought up, right? So this kind of intelligence is explicitly programmed by a human. It's already come to it, given the map, and we call these maps like rule engines, knowledge graphs, or the big one is quote unquote symbolic AI. This is kind of like what is known as the first wave of AI, which is all about the symbolic rules. So we don't have anything where the machine is like actually doing anything of intelligence. It's just kind of retrieving information. Yeah, so then you have the more recent one, which is like the one that people kind of see more, which is what I'm saying, the biologically inspired. So when we started thinking about these small and simple examples, and then we started to model, which came very early on, but there came the model of the artificial neural network, which is a very simple network that was modeled off of the way that we understood the brain at the time. So this is the essential model here, where you have a set of inputs on your right, on your left, most side here. This first row of circles are what are called weights. And that basically is like a bias. Humans are biased all the time, right? We have a bias towards something. So we perceive it that way. That's our way of perceiving. So we can actually weigh, it's called, you know, we can give it a certain amount of weight to kind of give it more value in the neuron. Then here is what's considered a transfer function, okay? And the activation function, and you have an activation. So this is like a lot of technical terms, and it doesn't mean that we don't need to learn them all. I'm just gonna kind of give you the narrative. I mean, but a transfer function here, we're gonna skip that because we're not gonna discuss that anymore. But it's essentially, I mean, it's just the way that that it's transitioning to be an input. But the activation function is most interesting because the activation function is a simple binary, which means yes or no, 0 or 1 answer based on a certain threshold. So there are different activation functions, and the activation functions become actually essentially at this time the most important part of the research because they're all different ways to kind of to model it. So if you think of in Photoshop, you have like a threshold filter, right? And you can kind of adjust the threshold filter on your black and white pixels, and it'll show you more or less information, right? And this is just like the abstraction of what these do. Again, here is a text encoder and an image encoder, and we see that we can then they basically then here's the labeling data up top and the prediction data. So here it can basically this is not quite a GAN, but it's a generative algorithm that works more like these encoders. So then basically what this part of the model does is I gave it the text, the book of imaginary beings, and it basically, let's see if I can find it. Like, okay, so see here how it can basically rate the different things here. It's because it's based on this giant model that it knows it can represent the relationship between image and text. And none of the stuff that I would give you is this complicated. I'm just kind of giving you a better visual example right now. But I can basically, I'm creating, I create a loss check. So what it does is it gets the image and it gets the text, and it relates that. It gets a big loss number, obviously, at the beginning, because my image is pure noise. So it has no, it basically means nothing. And the reason why it can gradually build is because it's basically optimizing that loss function as it goes. But there's like an artistic twist to the generation, like in that you can see I'm zooming in on the image. You can see it better when I make it a video, but I actually am moving the image at each point of the generation. But like, so like, what I think is really interesting about this aspect of it is that like, this is very plug and play.